Okay, so this is the page into 229, and this is 4.2. So if we look, it says Saturday morning, Erica walked for 30 minutes at a steady rate from her house to a park 3 miles away. So we definitely know that that 30 minutes is important. The 3 miles away is important. When she arrived, she played basketball for an hour, and then she caught a ride home with Kendall. They traveled at a constant speed from the park to Erica's house and arrived in 12 minutes. So when you look at this, there are multiple parts to this. We haven't done a ton of problems where there are multiple parts. There are different things going on. We've been looking at problems like this where the constant rate or the rental car cost, and it's just talking about one part or one cost and not where we have multiple things going on at the same time. So if we look at question 1, it says define the variables for time since Erica left her home in minutes and for her distance from home in miles. Remember, defining variables, that's where you're going to like give the letters that you're going to use. I'm going to go ahead and use X and Y. So X, remember, is the independent variable, Y is the dependent. So X would be time, and then Y is going to be her distance. If you look at your problem, or if you look at the problem, your important numbers are going to have a unit on them. So it's 30 minutes. So time is in minutes. And then distance is in miles. So you can always look at the units on the numbers to tell you what the units would be for your variables. All right, we're going to sketch a graph. So sketching a graph just means give a general picture of what it looks like. So we have time and distance. All right, go turn that. So if we look, again, there are 3 parts. She starts at her house. So she walked from her house. So her distance from her house, let's write that, from house. If she's starting at her house, then her house would be 0. Her house is 0 miles from her house. So she's going to start at her house and then she's going to walk away from her house. So if you think about it, as she's walking away, her distance is increasing. She's getting further and further away. Then she's going to stay at the park for an hour. So if she's at the park, is her distance from her house changing? No, she's just going to be at her house. So again, the distance is not changing. She's not getting further away. She's not getting closer. She's just staying at the park, but she's not at home. So we're not going to stay down here. Then she's going to go back home with her friend Kendall. So she's going to go back home with her friend Kendall, meaning she has to start where she's at, and then her distance is going to decrease as she gets closer and closer to her house, and then she gets back to her house. Okay, so that's what a sketch is. It's just giving a general idea. Remember, it's not talking about a hill. It's not saying she walked up the hill and then stopped at the hill and then went back down. It's her distance is getting further and further from her house. Then she's staying at the same distance from her house when she's at the park. And then her distance is going to decrease as she gets closer and closer back to her house. All right, now we're not going to do part 3. We're not going to determine the exact rate. Our biggest focus and what we're trying to work on today is creating the graph and talking about when it's increasing and decreasing. So if we look at part 4, we're not going to use the word domain. We're going to use time and distance. So when was she walking to the park? So if we look at this, she walked for 30 minutes. So if we think about when she's walking to the park, it took her 30 minutes. Well, when did time start? She started counting the time when she left her house. So when she left her house, that was 0 minutes. And then she walked to the park and it took her 30 minutes. So she was walking to the park from 0 to 30 minutes. How long was she playing basketball for? So it said she played for an hour. Well, we want to talk about the time since she left. So yes, it was an hour, but what time was that? So from 0 to 30 minutes, she was walking to the park. Then she starts at 30 minutes. It's already been 30 minutes since she left her house. So like if her mom said you can be gone for 2 hours or you can be gone for an hour and a half, this playing at the basketball, we need to account for the 30 minutes she already spent walking. So she's playing basketball from the 30-minute mark to what minute mark? So what's an hour more than 30 minutes? Well, that would be 30 plus 60 minutes. That's an hour. So that would be 90 minutes. So 30 to 90 minutes, she's playing basketball. Then she's riding home. We'll look back up at the problem. How long did it take her to get home? Well, it only took 12 minutes. So again, we're starting at 90 to how long did it take to get home is 12. So 90 plus 12, that'd be 2, 9, 10. So to 102 minutes. Okay, so we've accounted for how much time, like what all the time parts were. Now we're going to look at the distance. So how far did it say she had to walk to get to the park? So again, she started at her house, which is 0 miles away, to get to the park, which is 3 miles. So from 0 to 3 miles. So in the first 30 minutes, she went from 0 to 3 miles. Then she was playing basketball. What is happening with her distance from her house? So again, this is distance from house. How far away is she while she's playing basketball? Well, the entire time she's playing basketball, she's at the park, which is 3 miles away. So she's at 3 miles and she stays there. I'm just going to write the word stays because that's going to help us in a minute. Then she's riding home. Well, if she's at the park that's 3 miles away and then she rides home, she starts 3 miles away to her house, which how far is her house from her house? Is 0 miles. So she then goes from 3 miles to 0 miles. And I just wrote the word miles. Okay, so that's our table. This table is going to help us do our graph, which is right here. So again, time is X, distance is Y. So we're going to work on the graph, which is question 7. So we have time, which is on X, and distance, which is on Y. Okay. If we think about the time, our smallest amount of time is 0 and our largest amount of time is 102. So our time part of our graph needs to start at 0 and needs to get to 102. Don't just write 102 all the way over here. We need to decide how much we could go by. Well, I don't want to go by 1 hour, 2 hour, 3 hour. That's not going to help us. So let's go by 10 minutes. 10, 20. Now I'm going to turn my book because that's kind of hard to see. So I'm going to say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, which that's as far as we needed to get. Okay. Now distance, we only have to get to 3 miles. So I don't want to just go 1, 2, 3. I want to spread out my graph a little bit. So I'm going to make my graph go by 0.25. And I'm going to pause my video to do that. Okay, so I went 0.25, 0.50, 0.75, 1, Then I would do 1.25, and I'm going to pause the video again. Actually, I'm going to focus it first. There we go. Okay, then there's 1.25, 1.50, 1.75, 2.0, 2.25, 2.50, 2.75, and 3. And that's as far as I need to go. Okay, now let's go ahead and graph it. So the first part of the graph we said goes from 0 to 30 minutes. So we're going to start at 0, 0, and it's going to go to 30 minutes, and it's going to be 3 miles away. So in the first 30 minutes, she went 3 miles. So I'm going to graph that. And yes, I know I made a really good line. I've had some practice. Then the next part of the stuff is that she stayed there for an hour. So we're at 30 minutes and we need to get to 90 minutes. And she's going to stay there for an hour. Her distance is not changing. She is just playing at the park. Okay. Then from there, she needs to get back to her house, which is at 1 hour and 102 minutes. So I'm just going to put a mark down here. And again, she needs to get home. So that's why I'm back at 0. So then I'm going to graph that line. And so that's what our graph looks like. Okay. Over here to the side, we are going to describe what's happening. In each part. So we're going to call this part A, we're going to call this part B, and we're going to call this part C. So part A, if you look at the graph, what's happening to her or what is she doing? She's moving away from home. Or another way to say that is distance is increasing. Okay, her distance as she's moving is increasing. It's getting further and further. She's getting further and further from her house. Then part B, she stopped moving, or she stopped. Yeah, she's not. I guess she's technically moving, but she stopped getting further from her house. So stopped getting further. Her distance from home is not changing. Okay, and then part C, what is she doing? She's moving towards her house. And so her distance is decreasing. Okay, so her distance is going down. You can see the graph is going down. Okay, now let's look at this one. This is on the back side of that page, so page 232. On this, I want to go ahead and label each of these important points, kind of like we had all of those points on the last one. So A, B, C, D, E, and then F. I'm going to pause the video and I'm going to make a table right over here. Okay, so I just created a table over here. It says segment, and then I just did A, B, B, C, C, D, D, E, E, F. And then I have behavior. So behavior we're going to talk about is these increasing and decreasing. So the only words I want us to talk about is kind of like we did on the last one. When is it increasing? When is it decreasing? So from A to B, if we were talking about the distance and time again, our distance is going down. So it is decreasing. Okay, if we look from B to C, it's going up, meaning our distance went from 4 to 6.5. So our distance is increasing. And again, this is a different problem. This is a different graph. So we're looking at it. Then C to D. What is C to D? They stopped. It's not changing. Not changed. That's gonna have to live. From D to E, what is the graph doing again? It's going from, it started at 6.5 and went up to 9.5. So it is increasing again. And then the last part is going down. Think about your slopes is decreasing. Okay, now this is the next part that we're adding. It's called an interval. So we want to talk about the interval, or between what 2 points is that decreasing happening. So it starts at A and ends at B. So we're going to look on this part of the graph right here. It was decreasing, and we always use the input when we're talking about it. So interval, I'm going to put up here input or X. Okay, oops, sorry, I just hit my cabinet. So it would be from 0, what's halfway between 2 and 3 is 2.5. So it's from 0 to 2.5. And these are minutes. So you could put 2.5 minutes. Okay, I'm going to use a different color for this next one. From B to C, that's the next part of the graph. So that's from 2.5 to what's halfway between 4 and 5? That would be 4.5 minutes. Okay, the next part, let me get another color, is C to D, which is 4.5 to 7. So that's like saying from 4.5 to 7 minutes, they are stopped. They're not moving for this part of the graph. Okay, then the next part, if I could find, oh, there's an orange pen, is from here to there. That one's real short. So it's from 7.5, oh, sorry, 7 to 8 minutes. And then I don't have another color, so we're just going to go back to blue. And then from here to here, it is decreasing. So that's from 8 to 10 minutes. Okay, so we're just taking each of these parts and we're saying what is happening. So the interval at which it's decreasing or increasing or stopped or increasing or decreasing, we're just giving those values along the x-axis. So you kind of, hopefully you saw, kind of dropped that point down. And I was just giving the time at which it was doing that. Okay, this next one, I'm going to reword it a little bit. So it says, explain how the behavior of each part of the function relates to the slope. So I'm going to rewrite this, and I'm just going to say which segments had positive slope. And I'm going to pause the video and I'm going to write for negative slope and 0 slope. So just a second. Okay, so which segments had a positive slope, which segments had a negative slope, a slope of 0, and then I also added this question, which segment moved the fastest? So if we look, which ones have a positive slope? So I've talked about slope, dude. When are the slopes going up or increasing is what the new word we just used. So when is it increasing? So it's increasing from BC. It is also increasing from DE, which notice that's just in the table where we said increasing. Okay, which ones have a negative slope? So AB goes down or decreases, and EF also decreases. Okay, a slope of 0, meaning it's not changing. The slope is 0. Think about nice, negative, or 0 fun is when it's straight across like that. So that would just be part CD. And then now we want to look for when is it the fastest. So moving away or towards which one is the fastest, meaning it's kind of the steepest hill. If you were thinking about skiing, this one is kind of more flat. This one's pretty steep. That one's pretty steep. And then look at how this one goes all the way up here from 10 or 9.5 down to 10 in just a few seconds. So it would be segment EF is moving the fastest.